Okay, hi guys. This lesson is lesson 7.1, so if you go ahead and get that open in your calculator, it's in your new folder, Trig Applications. So go ahead and find that and get it opened up. All right, so what we're going to be talking about today, and this is going to be a 2 to 3 day lesson. Day 1 is going to be how we find area in triangles that don't contain a right angle. So we do actually have a formula that we use for that. It can be found on your reference sheet. So if you take a look on your reference sheet on the right hand side, you'll see where it says area of triangle, and it says K equals 1/2 AB sine C. We're going to be using that. So make sure you have that reference sheet out and available to you. All right, so go ahead and turn the page. All right, so let's start with what we know. We know that sine is opposite over hypotenuse. Oops, don't know what happened there. Okay, opposite over hypotenuse, we know that ratio. We know cosine is adjacent over hypotenuse. And we know tangent is opposite over adjacent. So we are going to be using these ratios. These things don't go away. All of the trig equations that we've spent time learning how to do, all of our special right triangles, our 30, 60, 90, our 45, 45, 90, all of the points that we learned, all of these things are going to come to play in this unit as well. So make sure that you're fresh and remember all of that important information. All right, let's take a peek at the next page. Okay, so on our first page here, we see we've got area of a triangle. For a triangle with sides, lengths A, B, and C, and notice those are lowercase. That's how we denote a side, is with a lowercase. An uppercase or a capital is going to be an angle. Okay? So for a triangle with sides, lengths A, B, and C, and opposite angles of A, B, and C, the area is given by, here's your formula, K equals 1/2 AB sine C. Now I want you to pay very close attention to something. Notice that this says side A, side B, okay, side A, side B, and then angle C, okay? So keep in mind where these things are. The angle is the included angle between the two sides that you're using, and that's very important. Okay, when we start finding the area of these non-right triangles, it has to be, you have to have two sides and the angle in between them, their included angle. That's very important. All right, okay, let's turn the page. All right, so which of the following represents the exact area in square inches of an equilateral triangle whose sides have a length of 10 inches. All right, exact. Remember, exact means we want those radicals, we want those fractions. I absolutely do not want decimal. A decimal is an approximation. So the most important thing about this unit is being able to draw what you're reading about, okay? So you have to have your notebooks out for this whole unit. You're going to be doing a ton of drawing. All right, so go ahead and in your notebook, I want you to sketch an equilateral triangle. Now, hopefully you remember that an equilateral triangle is a triangle with 3 equal sides. Okay, so I've got mine here. And it said that our equilateral triangle had lengths of 10 inches. So I'm going to go ahead and just label each side having 10. And we also, you know, a common thing to do is kind of put a little hash mark in there to say that they're equal, they're congruent. Okay, so think about if we have 3 equal sides, what else has to be equal? Well, since all of our sides are equal, then our angles also have to be equal. So if I know a triangle has 180 degrees for the sum of the interior angles, that means each one of these angles has to be 60. Okay? So I want the area. The area formula is K equals 1/2 AB sine C. And notice my A and B were lowercase, denoting sides, and my angle C was uppercase, denoting an angle. Okay? Now, like I said before, you have to have two sides and an angle in between. What's nice about this is we have everything. Okay? We have all three sides, we have the angle. So what I can do is I can just pick two sides, this side and this side. Okay, we can call this one A, we can call this one B, and the angle in between here would be C, right? Angle, angle, okay, ABC. So now all we need to do is some substitution. Okay, so K equals 1/2, A is 10, and I do want to put in my units 10 inches. B is also 10 inches. And sine of angle C, which we know to be 60 degrees. Okay. So now we're going to do the algebra. 10 times 10 is 100. 100 times a half is 50. And since we're doing inches times inches, that's inches squared. Think about we're dealing with area. Area is always units squared. And then sine of 60, here comes that first quadrant of the unit circle, guys. You have to have it memorized. Sine of 60 degrees is square root of 3/2. So, all we're going to do here is multiply. Remember, this is the same thing as 50 over 1. 50 times square root of 3 over 2. And of course, that reduces to be 25 radical 3 inches squared. So, 25 radical 3 inches squared is choice 4. And again, it's exact, so you're using that radical. Okay, let's go on to the next page. An isosceles triangle has legs of lengths of 12 inches and base angles that measure 32 degrees each. Find the area of this triangle to the nearest tenth of a square inch. Draw a picture to illustrate the triangle. So again, you are always drawing pictures, okay? So you have an isosceles triangle, two equal sides, base angles of 32 degrees each, and legs of length 12 inches. So let's go ahead and draw that picture. And again, it's an isosceles triangle. I'm going to make mine like this. Oops. Okay. So it said, again, it has legs of 12 inches. And base angles of 32 degrees. So we're putting in our information. And we want to find the area. Now again, remember, we need two sides and the angle in between. It's included angle, right? What's the problem here? What are we missing? So hopefully you're saying to yourself, we are missing the included angle. But that's really easy for us to find, okay? Here's my included angle, right? If I have these two angles, it's very simple to find my third angle. So we're just going to do 180 minus 32 minus 32, right? And that leaves us with 116 degrees. So my included angle is 116 degrees. And obviously this, I've made an acute angle. My triangle is a bit off. So my sketch isn't necessarily correct, but the rest of it is. Oops. Okay. All right, so now that we have the two sides and the angle in between, we can go ahead and substitute into my formula. K equals 1/2 A, so one of the sides, 12 inches. B, the other side, 12 inches. And sine of C, which we know to be 116 degrees. Now we wanted this to the nearest tenth of a square inch, so we are going to get a decimal value for this. So what we're going to do is we're going to go to our calculator and we're going to put this in. So I'm going to insert a calculator page, Control-I, add calculator. And we're going to go ahead and substitute this in. 1/2 times 12 times 12 times sine of 116. And remember, it's degrees, so you have to go up here and make sure that your angle is in degrees. If it's in radians, you need to switch it. Okay, so take a second to do that, please. Go ahead and hit enter, and we get 64.7132. So to the nearest tenth of a square inch, and what I mean by square inch is, remember, inch times inch gives you inches squared, is, now I've forgotten, 64.7 inches squared. And you need to make sure you're including your units, guys. It's very important. All right. Okay, so let's go on to the next one. Okay, so in triangle ABC shown below, AC is 24, BC is 30, and the measure of angle C is 40. Now, I've been nice enough to give you a picture here. You're welcome. So, what I want you to do is I want you to determine the area of triangle ABC to the nearest square centimeter. So, if the substitute could, please pause the video here, give them a few minutes to work, and when you're ready, go ahead and press play and we'll go over it. Okay, so we've got two sides, we've got the angle in between, which means we can go straight to our area formula. I just keep doing that. Okay. So A, we can say, is 30 centimeters. B is 24. And sine of 40. So you should have put this in your calculator. I don't need to show you how to plug things in. You guys are more than capable. You should have gotten 231.403539, and that's centimeters squared. And since we wanted that to the nearest square centimeter, you should have had 231 centimeters squared. All right, I hope you guys are getting this. So using your answer from part A, determine the length of the altitude drawn from A to side BC to the nearest centimeter. Okay, so your altitude is your height. So A to BC. And what that does is it creates a right triangle. So this blue line here represents your altitude. So we need to think about how we can find that. All right, let's think about what we have and what we want. We call it X. All right, so let's think about those trig ratios we talked about at the very beginning. We said sine was opposite over hypotenuse, cosine was adjacent over hypotenuse, and tangent was opposite over adjacent, right? So let's think about what we have here. If we're talking from going from the angle that we are given, this 40-degree angle, what sides do we have? Okay, well, we know that we're looking for the opposite, and we have the adjacent. We also have the hypotenuse. So we actually have two options here. We could use opposite adjacent tangent or opposite hypotenuse sine. And since we don't use tangent a whole lot, I want to use tangent. All right, so this goes back to 9th grade. You learned how to do this in 9th grade. We're going to set up a ratio. So I know tangent of 40 equals opposite over adjacent. Okay. And so all I'm going to do is I'm going to clear this fraction by multiplying by 24, or we could say cross multiply, right? So 24 centimeters times tangent of 40, and that equals x. You're going to go ahead and pop that into your calculator. I'm not doing it for you. Please take a second to do it. You should get it to be 20.138 3911. And it did ask it to the nearest, everything else is written to the nearest centimeter. So we're going to go ahead and say that it's 20 centimeters. And that's it. That is an approximation, as is this. Okay. So there we go. We're going to do one more, and then you guys are going to start your homework. All right, so a garden is being designed in the shape of a parallelogram whose sides have lengths of 40 feet and 30 feet. If the acute angle of the parallelogram measures 45 degrees, determine to the nearest square foot the area of the garden. So what you're going to do is you're going to go ahead and in your notebook, you're going to draw a parallelogram. You're going to label two sides 30 and 40, and you're going to label the acute angle 45 degrees. And we're going to talk about how we find the area of this parallelogram. Okay, so I've got my parallelogram. I'm going to label my sides 30 and 40. And this is feet. And it says the acute angle, so the one that's less than 90 degrees, has an angle measure of 45. Okay. I want the area of this garden. So now, if I think about it, really, all a parallelogram is it's two triangles that have been put together. So if I think about taking this triangle and cutting it in half, what I've done is I've created two congruent triangles. Okay, this we know is a side of 30. This is 40, right? Opposite sides of a parallelogram are congruent. The angle here is 45. Okay, so all it is two of the same triangle. So all I have to do is, if I find the area of this triangle here, all I need to do is double it. Okay, so I can take my area of my triangle and multiply it by 2. All right, well, straight off the bat, 2 times a half I know is 1. So what I do, let's just get rid of that 1/2. Whoops. Got a little crazy there. And now I can plug in my information. So again, it doesn't matter if A is 40 or B is 40. Multiplication is commutative. It's going to work either way. So 40 feet times 30 feet times sine of 45. And you guys know off the top of your head, sine of 45 is square root of 2 over 2. But since we want this to the nearest square foot, we're going to use our calculator and get the decimal approximation here. Okay, 30 times 40 I know is 1200, and that's going to be feet squared times sine of 45. You're going to go ahead and put that right into your calculator. 1200 times sine of 45. Then we get 848.528. And since we need this to the nearest square foot, it's going to be 849 feet squared. Now, guys, big warning here. Big warning. This is not the same thing as this. Okay, please do not make this mistake. If you do, your answer is totally wrong. Okay, so please keep that in mind. You're squaring the feet, you are not squaring the value. Okay, so please be careful of that. All right, good. So your homework tonight is pages 2 and 3 in your Unit 7 packet. Okay, I expect that to be done for Monday. I will be back on Monday. So don't forget your weekly project 17 is also due on Monday. I will be collecting that as soon as you walk in the door. So have that ready to go. All work must be in there. And I will see you guys Monday. I hope you've had a good couple of days without me. I'll see you soon. Bye.